Yeah, okay. Hi, hello. My name is Takuya from NOJ. I'm also appointed staff of SKO in charge of the planning of the Cosmic Magnetism Science Data Challenge of SK. But I'm not talking about science. So in my poster, I briefly introduce our vision, Japanese vision of the SK Region Center. Then the key message here is that JPSC would like to unite two subsystems. One is actually the SRC node in Japan. The other one is the national node for the university's SK community. So we have some ideas to unite this using the virtualization technology such as OpenStack, and also the container management and the orchestration technologies such as Kubernetes, and also of course Dockers and Singularities and so on. And in my poster also, I briefly introduce our activities in the SRC art, Agile Release Train. And also we are proposing some Japan-made technologies such as vector engine, Tsubosa, and also the GFARM, that is a distributed data file system developed in the Lattice QCD community. Thank you.
Hi everyone, I'm Adam Avison. I'm an operations scientist at the SKA, and my poster is about the Observatory Science Operations Software Suite. That's the collection of software tools that will be available to take your science idea and run it through the telescope and get you some science out in the end. We stop at the point where we start it running on the telescope. They say a picture says 1,000 words. I'm hoping that this diagram will do that for me, given the amount of time I have. It shows the tools that will be used by various users. So the science users in the room will be mostly interested in the beginning, and the project tracker, there's a slight omission there. Yes, you'll also see the SKA's fondness for three-letter acronyms is very prevalent on that plot. So if you have any questions about this, come see my poster, it's number 2, so cheers.
Hi, so my name is Lars. I work at SOFIA, and my poster focuses on molecular cloud formation and thus how star formation is initiated, and in particular also how high mass star formation is initiated. So in the poster I present results with a couple of star forming regions that we've studied, where we maybe surprisingly find that both low and high mass star forming regions show quite similar dynamical features, suggesting that they might be forming in a very similar way. So when it comes to the SKA, NGVLA, and the precursors as well, we will be able to resolve much more molecular clouds or a larger sample. And with complementary data, we'll be able to, on a statistical basis, to constrain what initiates star formation. So if you're interested in that, please come see my poster or come talk to me. Thank you.
Hello, my name is Micah Bowles. I'm a PhD student at the University of Manchester, supervised by Professor Anna Scaife. Ignore the animal on the left. For those of you that know that, please have a little chuckle. But essentially, my work recently has been focusing on how we use language to classify extended radio objects in the extragalactic sky. And specifically, I have contention with a lot of the terms that we currently use. And so in the collaboration of the Radio Galaxy Zoo EMU project, we've worked to build a set of terms that are plain English, that anyone can use, and that are dictionary based. So if you don't understand them, open a dictionary and you should be able to go. So that should allow much more usability of these terms and much more fine-tuned control over what you're actually looking for in the sky. Thank you. P7.
Hello, my poster is I'm Gabriele Bruni, works in Bologna, and in our latest work we used the latest generation radio service, VLAS and RAX, to try to resolve the radio counterpart of misaligned AGN in the Fermi-Lat catalog. So we found a remarkable example of an FR2 radio galaxy with a gamma ray emission that is 10 times more than what expected from the core. So modeling the broadband SED, we could explain this as an emission from the lobes via inverse Compton of the plasma of the photons fields, local photon fields, and we found also more example of radio galaxy-like morphologies in Fermi-Lat objects. So we foresee that with the next generation of radio service, SKA and GVLA, we will be able to see an emerging population of gamma-emitting radio galaxies that are so far below the threshold. Thanks.
Hi all, I'm Seth Bruzewski. I'm a graduate student from the University of New Mexico. For the last little bit, my work is mainly focused on J002 plus 6216, a sort of beautiful system that you can see here on the left-hand side, which is a gamma ray pulsar shot out of a supernova remnant, and a fairly obvious story here. And so this analysis was done originally in Shenzhen 2019, where they looked at the gamma ray timing and sort of various models of the distance to get something to a velocity, which gave you a velocity of over 1,000 kilometers per second, making it one of the fastest pulsars ever discovered. And so we've been trying to get a more accurate measure and a more accurate handle on the distance and proper motion using parallax techniques with VLBI. Right now, I've got some interesting results that we've got on the poster P9. If you'd like to check that out, feel free to come by.
Hi, everybody. My name is Alyssa Bulatek, and I'm a third-year grad student at the University of Florida, working with Adam Ginsberg. Here's my poster. It talks about as part of a line survey of the Galactic Center molecular cloud, the BRIC, we detected the 107 gigahertz transition of methanol undergoing this process called dazing, which is essentially absorption against the cosmic microwave background. And this happens because some pumping mechanism pumps molecules into the lower state preferentially of a two-state system, and you get absorption of CMB photons. You can use non-LTE modeling to back out the physical conditions that cause this level of absorption. So we show that, and we also outline possibilities for a deep field survey using NGVLA to observe a few methanol Dazar transitions to measure star forming regions in high redshift galaxies. Thanks. My poster is P10.
Yep, hello everyone. I'm James Collinson from the Data Operations Group at SKO, and I'm here to present the current state of technical progress in the SRC network, the SKA Regional Center Network. So this is the global network of data centers we've heard a bit about already. As Phil mentioned earlier, SKA data is going to be too big for astronomers to download and process locally. So the regional centers are how the astronomers are going to be able to turn the SKA data products into science results. Currently, we're at the prototyping stage, so we're looking at the technologies and software that will enable us to deliver these data centers. And SKO is involved coordinating the global technical effort, so from software development to software product management. So we're considering this from the user perspective by thinking about the capabilities we need these SRCs to have, and then thinking about the technologies that will enable us to meet these capabilities and how the software can help us achieve those. So if you're interested in hearing about how the SRCs will work, or the specific technologies that we're currently considering to deliver these, or if you work for the NGVLA data operations or software teams, then I'd love to have a chat. Thanks very much.
Hi, my name's Jaiden Cook, and I'm a PhD student at Curtin University in Western Australia, and my poster is on the cosmological 21 centimeter skew spectrum during the epoch of reionization. The skew spectrum is the integrated biospectrum, which is essentially just a measure of the third order statistical moment of some random field as a function of spatial scale. The reason this is important is because different physical mechanisms like ionization morphology due to UV photons and X-ray heating of the 21 centimeter or the neutral hydrogen will affect the statistical moments. So in this work, we look at a set of 7 different cosmological simulations, which vary the ionization morphology and the X-ray heating through the X-ray hardness of the spectrum and the luminosity. We calculate the skew spectrum as a function of redshift and spatial scale to see how these different mechanisms affect the high order statistical moments. Thank you. If you'd like to know more, please check out my poster on Slack, or you can just come chat to me. Cheers.
Hi everyone, my name's Nathan Dagg. I'm based at Queen's University in Canada, not Belfast. My poster is on the kinematic models that we're building for the Wallaby survey, and it's specifically talking about the proto pipeline that we've used to generate 109 kinematic models for the first pilot data release, as well as the next 127 that are coming on the next data release. So like I said, the poster describes these technical models that look kind of like that. Come see the poster, not at P14, at P60A, or message me on Slack and we can talk about it. Have a great day. Thanks.
Okay, hello everyone. My name is Wael. I'm from the SETI Institute, and I am the project scientist for the Allen Telescope Array, a telescope that was once the pathfinder to many of the next generation telescopes that we're seeing here today. The Allen Telescope Array has undergone a big refurbishment program that resulted in a much more sensitive feed and a revamped digital signal processing pipeline. If you are interested in fast radio bursts, pulsars, slow transients, search for extraterrestrial intelligence, please come find me. My poster is outside P17, P17. Thank you.
Hi everyone, my name is Marilou. I am based at IAA in Granada, where I am part of the team that coordinate the participation of Spain in SKAO. On this poster, I'm presenting actually two images of Benjet radio galaxies that are located in the nearby Perseus cluster. And these are actually VLA images, and you can see a lot of details in those radio tails, morphologies that are linked with the cluster, intra-cluster medium, right? And this is kind of just a start of what we can do with these galaxies. SKA is going to detect much more, of course, of these galaxies, and NGVLA is going to be able to resolve in even more details these radio tails. And together, we will have access to the full frequency range to study their spectral properties. So if you want to know more about this, you can come and talk to me. I've put the poster on Slack. Thank you.
Hi, I'm Hansung Gim from Montana State University. The goals of this study are to investigate the microjansky radio source populations with unprecedented sensitivity and to explore the star formation and black hole activities across the redshift. So we present the Chilis COMPOL, the commensal radio continuum and polarization observations from the Cosmos H1 Large Extragalactic Survey obtained for 1,002 hours with the RMS noise less than 1 microjansky. The multi-wavelength study shows the radio sources less than 10 microjansky are dominated by star formation, which is consistent with the number count study. So my poster is at P23. So for more details, so come to see my poster. Thank you so much.
Hi, I'm Alberto Bolatto from the University of Maryland, and this is about poster P4. So in the US, the decadal survey process identified as one of the key open questions in astronomy, the question of how baryons move into, through, and out of galaxies. And the purpose of the poster is to connect to the NGVLA and the SKA and how they can uniquely illuminate several aspects of this question. So another thing that I want to highlight is that the VLA is already investing a significant amount of time to produce observations of quality comparable to what we be routinely done with the new instrumentation. And in particular, there is this extra large survey, extra large proposal that was approved to survey 6 galaxies in the local group to very high depth and resolution in L-band. And the leadership of the survey is here. You can talk to Eric Koch and Eric Roselowski. And finally, one of the other recommendations of the decadal was essentially the production of a probe class mission by NASA in the infrared and in X-rays. And I'm, of course, very excited about the infrared in particular, because that will have a lot of synergies with what can be done with SKA and the NGVLA. Thank you.
Okay, my name is Denis Leahy, University of Calgary. This poster is about a study of QCD phase transitions on cosmology. So this is fairly early times, the universe cooling down from hundreds of MeV to below keV temperatures. There are three major phase transitions. The first one at about 10 MeV is conversion of quark gluon plasma to baryons, plus 10% by mass, but 90% by mass of quark clusters. The quark clusters can provide the dark matter. Second phase transition is from unpaired QCD matter to color superconducting matter, which releases 2 MeV photons at a temperature somewhat below 10 K. When the universe temperature is somewhat below 10 keV, the 2 MeV photons destroy beryllium-7 to resolve the lithium problem. The third phase transition is speculated to occur at gigayears, so at redshifts between 2 and 5. And this phase transition is the QCD vacuum leaking out into the surrounding space-time vacuum, so that the cosmological constant only appears, it's non-zero after redshift 2 to 5 and 0 before that. If you calculate the cosmology with that, the apparent Hubble constant at recombination is 67, and the current Hubble constant is 73, so that resolves the Hubble tension. See the poster for details.
Hello, my name is Bunyo Hatsukade from the National Astronomical Observatory of Japan. So the NGVLA study group in Japan, organized under the NLJ, has been studying how Japan can contribute to the construction or operation of the NGVLA. And the science working groups in Japan, which constitute of the researchers in the astronomical community in Japan, have discussed the possible science cases with NGVLA. And following the poster 1, which describes our activities and present science cases on galactic science cases, this poster 2 presents the highlights from the extragalactic science cases and present some showcases. So if you are interested, please see this poster, and also visit this website of the NGVLA memo series in Japan. Thank you.
Hello, my name is Tomoya Hirota from NLJ. I belong to Misa Behavior Observatory and SK and Japan Promotion Group. And we review the recent study of the nearest high mass protostar object, Orion Solstice. As shown here, we revealed the disk and outflow system in Orion Solstice, but due to the high opacity at millimeter and sub-millimeter wavelengths and low sensitivity and resolution at lower frequency band, we could not resolve the innermost region at a resolution of 10 AU scale. So we need SKA and NGVLA. For more details, please visit the poster. Thank you.